ipsec Part 1. In this nugget, we discuss ipsec, which is a very complex standard comprised of hundreds of pages in RFCs, but we'll take a look specifically at the various policy components of a Windows Server 2003 policy. There's a lot there. I mean, you have to determine what kind of a hashing algorithm you want to use, what kind of integrity you want to use, whether you want to use authentication header just to authenticate both parties, whether you want to use encryption of the payload, all different kinds of things involved, and it's very complex. So we'll take a look at the basic components to get a groundwork understanding of it. And if you've seen previous nuggets that I've done where I've also talked about ipsec, this might be nothing new to you, as well as the brief section where I'll have on creating an ipsec console. However, there are some new spins on creating a policy because we'll take a look at how to enable a policy to encounter two different types of network traffic, specifically how to block all network traffic while at the same time allowing traffic to a single host. So we'll take a look at how to do something like that. And then the next nugget, we'll go ahead and enable that policy, assign it, and go ahead and see it in action. You know, a couple months back, I got an email. It was an interesting email. It was in an HTML format, so I was able to save it in HTML format, so that's why I was able to open it here. But it was an email from PayPal saying that we need to confirm your information as a recent measure to protect our customers. Okay, and it looks like, you know, they're going to take me to certain secure websites to do this. So if I click follow this link, down here at the bottom you see it says HTTPS. That appears to be where it's going to try to take me. If I go ahead and click on any of these links up here, click on PayPal up here again, it takes me to the HTTPS site. So it looks like it's going to really take me to the appropriate location. And I'm wondering why they're sending me this in the first place. They're just trying to keep in touch, okay? They want to make sure that it increases security, it verifies my account. There will be no limit on the amount of money I can send through PayPal. Wow, imagine that. I'm trying to think also why they sent me this now, because I haven't bought anything through PayPal for a long time. I think the last time I bought something through PayPal was those Star Trek action figures from eBay. So other than that, I can't think of any reason why I would be getting this from PayPal. Oh, it looks kind of legitimate over here too. It's telling me the phone numbers for banks that I can use, and my bank is listed in this list of banks that they have here, so that looked pretty legitimate. However, if I follow the link that they tell me to click on, if I click says follow this link, I hover over it, looks like again it's going to take me to https://www.paypal.com. So I click on it, and just wait a little while, and where does it actually take me? Actually, the link is broken now, but we'll see where it takes us in a moment here. It takes me to an IP address, and it is not an HTTPS location. And I did a whois using NSI.com. I did a whois on the IP address that'll pop up here in a minute. Turns out it's from a company in Shanghai, China. There's the IP address. Notice that it's not secured. And it takes you to a website originally when you did this that looks exactly like the PayPal website. It has all the PayPal icons on there and everything like that. Well, as you may have guessed by now, this is actually a scam. What they're doing here is they're getting gullible people to enter in all of their information, their bank account numbers included, their social security number, all kinds of stuff like this, and whoever was doing this was skimming this information off and then robbing people's bank accounts and manipulating them and stuff like that. Well, rest assured, I'm smarter than that, so I didn't actually enter anything in there, but it was a curiosity, and I did notify PayPal. And by the way, to PayPal's credit, they cracked down on this. I mean, this site was only up for a short while before I'm assuming that under pressure from PayPal, it was brought down. And they also posted a notice right on their homepage about this kind of an exploit. Apparently, there was this one and maybe some others that were going on at the same time where people were trying to skim this information. Well, the reason why a lot of people fell for that was because they don't know anything about systems. I mean, these are mostly end users that are falling for this, you know, just home users and stuff like that. And they don't have any built-in authentication in their computer that would just pop up a message and say, warning, this is not who it says it is, or any other kind of thing that would just automatically deny the traffic for them if the authentication did not take place, authenticating that the other party there really was PayPal or really was not PayPal in this case. Well, in a corporate environment, you can use ipsec to verify that messages are from who they say they are. There's a number of ways of doing it. One of the ways is to use ipsec. And in this nugget, we're going to take a look at ipsec and specifically get an overview of the various ipsec policy components. So as we get started with this, let's go ahead and first take a peek at what an ipsec rule is. And I'm going to take you through the interface. We're actually going to see where all these take place in just a moment. But first, let's just kind of get an overview of them. First of all, you have to have ipsec rules. Now, a rule consists of an IP filter list and a corresponding IP filter action. So really, these are all the same thing. They're all just kind of wrapped up within one another. A rule consists of a filter list and a filter action. The filter list might identify something, for example, like a destination IP address that says anytime I get an IP address that's trying to communicate with me at 10.10.10.5, I want to trigger this filter action, which could be to deny traffic, for example. Maybe that's an unprotected or an unsecured workstation or unsecured server. Or you might want to block traffic to everybody except for 10.10.10.5, and for that filter action, you're going to negotiate security. And then when it comes to negotiating security, you have to determine what security method you're going to use. What you could do there is to just authenticate the header, and that would not encrypt the contents of the packets. And then authenticating the header would just identify and verify that, yeah, you are who you say you are when we communicate. Therefore, I know that you're not some fake PayPal or some fake other party there, somebody who's performed a man-in-the-middle attack, which means that someone's grabbed packets out of the air over the wire and then repackaged them somehow and pretended to send them from the same party from which they originally came from. Well, we can use authentication header to confirm that you are who you say you are. Or we can use ESP, or encapsulating security payload, to heavily encrypt the contents of that packet. And then you could also use both AH and ESP, but it's a little bit uncommon. Now, ESP also has built in it authentication methods as well. So if you use ESP, you might not need to use AH. Then there's authentication itself that takes place so that during the negotiation of these two parties in the IPsec communique, there has to be a determination of authenticating that you are who you say you are. It's kind of a pre-authentication, really, so that once we determine that you are who you say you are, then we can set up more secure methods of authenticating our traffic thereafter. There are three methods of that authentication. You could use Kerberos authentication if both parties are within the same realm or the same domain. You can also use a certificate for authentication. This might be a certificate that comes from a certificate authority, such as VeriSign or somebody like that. And then you can also just use a pre-shared key, which obviously would have security limitations. Then you can also do tunnel setting. For example, we want to be able to determine whether or not this is being sent between two routers over something like a WAN or a public internet connection. And if that's the case, we want to make sure that both those endpoints will be able to support tunneling with IPsec. And then on the other hand, if you decide not to use tunneling, that's what we call transport mode. And then you can also determine the connection type. You want it to use for LAN traffic only, that's LAN, LAN traffic, or for dial-up traffic only, or for both. And so you need to make that decision as well. And all of this really comes pre-packaged for you in Wizard so that you can easily determine what you need to do. Of course, you need to have a plan of action before you start all of this so that you know where you want to go with your security plan. Then the Wizard really becomes easy because you just fill in the blanks for what you want to do. Now then, when it comes to implementing your IPsec policies, there's two ways of doing it. You can use Active Directory users and computers, or you can do a local policy. And for most of the things I've talked about in the past, a lot of what we'll do is by group policy objects instead, which will be by using Active Directory users and computers and configuring a policy on our specific OU. That way it applies to kind of a shotgun blast of a whole bunch of computers or a whole bunch of users, respectively. In this case, however, sometimes you'll do this on a onesie-twosie basis where you're really just isolating individual computers and you want to isolate them in terms of security. So you might do an MMC console by just going to Start Run, typing MMC, and you want to add in two snap-ins to make this work. You'll go ahead and add in IPsec policies. One of them is a monitor. That's the IP security monitor. I'll double click on that. We'll be using that a little bit later to show you some basic information about monitoring. And then IP security policy management. And you see that you can identify this for the local computer, Active Directory, or for the current domain or another computer. I'll just use the local computer for the time being and then close all this up because I'll use IPsec policies for the domain or organizational units a little bit later on using Active Directory users and computers. Now, what we're mostly concerned with right now is the IP security policies on the local computer. Now, although Microsoft gives us 3 default policies here, and you should understand what they each do, the main purpose of each one of these is really for your own understanding and for your own template, if you will, so you can kind of crack them open and get an idea of what's there and know how they work. And you should know how they work anyway, even if you don't actually use them, because Microsoft uses them in all of their documentation, and anything you read from Microsoft relating to IPsec will probably refer to one of these 3 policies. Now, I'm also going to create a policy from scratch, and the purpose of that really isn't so that I can show you how to create a policy of your own from scratch as much as it is to show you how it would plug into or be implemented in a real network design. Because at this level, we're a little past the step-by-step of how you do this and how you do that. It's mostly now how we're actually going to take something and enact it and enable it in the real world here. For example, here I've got a SQL server. It's got confidential information on it, highly secretive information. And I don't want any of my users out here on the rest of the network to be able to access this SQL server. Now, I could do something like TCP/IP filtering, where I can just block all traffic. But I do want to allow traffic to this application server over here, because what's going to happen is this application server is the only one that's allowed to communicate with a SQL server, and it pre-packages all of the SQL data that it mines out of the SQL server into these handy little HTML pages that I do make available to the rest of my network. So everybody sees the data only after we've specially manipulated it and made it look all pretty and stuff like that. Maybe we also make it look like we're more profitable than we really are or something like that. It's probably a Enron server, a Tyco server, something like that. Now then, I need to go ahead and create a policy, and the only thing I really have to do here is to right-click and choose Create IP Security Policy, which starts the wizard. I go ahead and click Next and enter in a meaningful name. So we'll give it a name something like this, which means I want to block all traffic except for using the encapsulating security payload to DC Nugget 1 and DC Nugget 3 traffic. Then we'll go ahead and click on Next. And we could activate the default response rule, but it's less secure than the other settings that I could enable. And if those other settings do not communicate properly with another host, if they can't negotiate or agree upon common settings, it could default back to this default response rule or fall back to that rule. And I don't want to potentially use a lesser level of security, so I'll clear that checkbox. And we'll see exactly what that rule is a little bit later on. Then we'll click Next and Finish. Now, this was actually the first of, believe it or not, 4 wizards that we're going to use to actually create this policy from start to finish. And we'll start the next one after we click on Edit Properties here. This is selected by default and click Finish. And it opens up the properties for the policy we just created, which does nothing, because there's no selected checkbox for any of the IP security rules. You see, we only have one rule there, that's the default response rule, which we already decided we would not use. And the less secure parts of this are that the key lifetimes are 0 and 0, which means that they don't have an expiration. And it might be best if you have an expiration for the key lifetime so that after a certain number of packets, or rather a certain number of kilobytes, or after a certain number of seconds, those keys expire and are renewed or regenerated. And then if it can't negotiate using the first level of security that we see up there, then it'll go down to the next one, next one, next one, next one, which is actually an authentication header integrity security, down to the final lowest one, which is MD5, 128-bit integrity. And that's just less security than I could get by myself by otherwise creating my own rule here, which I'll do now by using the wizard after having clicked on Add and leaving this checkbox selected. And then it starts my wizard number 2. Now what I want to do is to specify whether or not we're going to use transport mode. And that's exactly what this is up here, where you do not specify a tunnel. If I had routers on opposite ends of a WAN connection, or opposite ends of a public internet connection, I might use ipsec compatible routers, which is where I would choose the tunnel endpoint here. This would be tunnel mode then if I did this. And then I would enter in the IP address of whatever the destination router's IP address is. And then my routers have to be able to support ipsec. And what they will do then is they will take ordinary network traffic from us, package it up in IPsec packets, send it along the wire encrypted or authenticated, and then on the receiving end, that destination router will then decrypt all of it and perform all of its authentication. Then it passes it on to its network as ordinary network packets. In this case, we're just going to use transport mode, and that's probably what you're going to use most of the time. And we'll click on Next here to use all network connections, not just LAN or just RAS. And then we need to specify what we want this to do. Now we've configured here an IP filter rule. Now that we've got our rule, however, we need to give it a filter list, which is part of the rule. And the first thing I want to do is to just block all IP traffic. So I'm going to select that. Notice these are also radio buttons. You can't just select both of these. You have to select only one or the other, or add an additional filter list item. We'll be doing that later on. For right now, we'll choose all IP traffic, and then what we want to do, it's not permit it, not request security, and not require security. None of those work for us. We want to block the traffic entirely. So I'll click on Add here by using the wizard, which starts wizard number 3, and we'll click on Next, and I'll tell it what I want it to do. Block all IP is what I'll say here for this, and hit Next, and I want to block all traffic. That's the action that I want to take place. If I had chosen negotiate security, then I could choose what kind of security negotiation I wanted. In this case, it's not relevant because we're not doing anything. We're just blocking it. So then I'll just click Next and then Finish. Now, having done that, it dumps us back into our original wizard here. So I now have this block all IP filter action that was generated by clicking on add by using the wizard here. That's what I've got now, block all IP traffic. Then I'll go ahead and click on next and finish here, and we're left with the dialog box that kind of pre-packages all of the items that we selected in the wizards all in one dialog box for us. So let's just summarize what we've really got here. What's going to happen with this rule is it's going to look at all IP traffic. When it sees all IP traffic, it blocks it just flatly. No exceptions to this right now. The authentication methods don't matter. It would have chosen Kerberos, but we don't care if you're authenticated or not. You're not getting in. And then we have a tunnel setting of transport mode and the connection type of all network connections. So that's pretty much it. We just OK that. And then we can click OK again if we like here. And now, if I activate this policy and assign this policy by right-clicking and choosing Assign, which would then turn this green little dot there and then turn on the policy by saying yes over to the right, then this would block all traffic everywhere. I don't really want that right now. I want to unassign that. Because what I really want to do is to block all IP traffic except for traffic with DC Nugget 3. So what I'll do is go back into the properties of this and add an additional security rule now for traffic to DC Nugget 3, which its IP address is 10.10.10.23. So I'll click on Add here and add a new security rule. And this is the same item that we looked at before, so we'll kind of quickly go through this part of it. Now here's where things are different. I don't care if it's all IP traffic or ICMP traffic. I'm looking for a traffic pattern to a specific host. So I'll click on Add now, and I'm going to enter in the IP address for the host that I want. Once I click on Add here and use another wizard. And I'll just call this DCN1 to DCN3, and I'll click on Add again by using the wizard, which starts another filter wizard. Then I'll click on Next. And then what I can do here is to enter in a description, and then I'll specify whether or not want this to be mirrored. This means that the exact opposite source and destination addresses are going to be included in the filter list and in the rules that we create. This prevents me from having to create an exact duplicate filter for receiving traffic. You don't actually see both halves of it. You only see the side that you create here, but there's actually both sides there. And I'm going to go ahead and enter a description as well, and just for fun here, saying that we're going to allow traffic between DC Nugget 1 and DC Nugget 3, and then we specify the source address. The source address is traffic that's coming from DC Nugget 3, so I'll specify a specific IP address. I could do a DNS name as well. You do have to consider certain things like this, though. If I have to access a DNS server, then that has to also be added to my filter list here. Because if I specify a DNS name, but I don't allow traffic to that DNS server, well, how am I ever going to resolve the names? So you probably won't run into that in a lot of situations until you actually implement this in real world, but in a lab you might not see this until you really run into problems. So just be aware of that kind of thing. You can't depend on any of these other kinds of servers or IP addresses unless you have a way of accessing them. I'll specify a specific IP address here, and I'll enter in 10.10.10.23, which is DC Nugget 3, and then I'll click on Next. And then the destination address will be me, so it's my IP address, and then I'll click Next. And then we could also be as granular as to specify any kind of traffic. For example, if my application on DC Nugget 3 used TCP port, I don't know, 5589, then I would click Next, and then I would specify the port numbers in this. I don't need to do that for our case. I'm just going to leave it open at any protocol between those two servers, and then I'll just go ahead and click on Next. The same thing would happen, by the way, if I used a UDP protocol in this list. Then if I chose that, then it would again allow me to choose a port number. And then you have these several other protocols available to you as well. So I'll just click on Next. I can edit the properties if I want when I finish the wizard, and it brings it all again to me in a packaged view here. So I could say any source addresses, any traffic coming from this specific IP address to my IP address using any protocol, and this is the description just for my information. What's going to happen with it? Well, we don't know yet. We haven't finished everything yet. Because all I've done so far is to create another part of the filter list. So I click OK here, and now I've got this little guy to click on. Next thing I can do is to go next through the wizard, and this time I'm going to say permit traffic if I want it to be unsecured. That's probably not going to meet with my objective here because I want this traffic to be IPsec encrypted so that people can't just pick it up off the wire. Because traffic between any hosts on a network is really available to for anybody to see. There's really no way to hide that unless you encrypt it. So that's what I'm going to do here. Oops, where'd my little dialog box go? There we go. So what I'm going to do here is to require security. I'm not even going to request it. Again, we'll talk about what require and request security are a little bit more when we get further on into this. But require security means that it will accept unsecured communication from a host, but it will only respond to negotiate IPsec security. And if the other end of the communique doesn't understand that kind of communication or cannot negotiate with the host, then there's really nothing else that happens. Just traffic just starts dropping. So I'm going to require the security and click on Next, and then I specify what kind of authentication I want to use to verify that both parties in this communique are indeed who they say they are. Since both these servers are in the same Active Directory domain, I'll just use Active Directory Kerberos version 5, which is an excellent method of authentication, so we'll just leave it at that. We can also choose a certificate authority, either an internal one if we had an enterprise root, or an issuing CA or something like that. Any other kind of CA that could issue certificates, well, we could choose certificates from that certificate authority. And then one thing that's new here with Windows Server 2003 is that you can exclude the name of the CA name from the certificate request. Because during the authentication process here, someone could still pick the packets off the wire and determine what the name of the CA is in Windows 2000. In Windows Server 2003, it's more secure to select this checkbox, which prevents them from getting a head start on knowing who your CA is. I can also enable certificate to account mapping so that once authentication is performed, then whoever the opposite party is here will have the same security rights as a certain account that might be on ACLs for various applications or printer permissions or for file permissions of some kind, that kind of stuff. Another thing we could do here is to use a string to protect the key exchange. I don't really recommend this for most purposes. It might be useful in a lab if you just want to check out the basics of authentication here, but both parties on both ends of this have to know what the key is, so you just type in whatever, and then you call the other person on the phone and you say, hey, the secret password is whatever you got in here. The problem with that is if you are in Active Directory here when you create this policy and enact this policy, then this will be stored in hex values in the Active Directory. And just about everybody has read access to Active Directory, even users, so somebody could divine out this information if they knew where to look for it. Also, it appears in plain text in the local registry if you're not using Active Directory, but if you're using a local policy, it appears in plain text in the registry. Now, the things you want to keep in mind as well in terms of internet traffic are this with these top two items. First of all, you certainly want to use this checkbox on the internet because there's too broad of a base. You really have a broad attack surface by leaving this cleared. So make sure you check that for internet traffic, and then try not to ever use this on the internet, because this includes the name of the domain and some other sensitive security information, and you don't want that packing across the internet, so just be careful about that. For our purposes, as this is all local communications within our own network, we'll stick with Kerberos, and then again, you can edit the properties when you finish this if you want, and now we see the filter list item here. DC Nugget 1 to DC Nugget 3 is going to take this action. It's going to require security. It's going to use Kerberos authentication without tunneling, in other words, transport mode for all connection types. And now we've got that in place, we'll just click OK, and now you see that we have two enacted security rules going on here. And what happens is the most specific rule always applies. So if my IP address is 10.10.10.23 and I attempt to communicate with DC Nugget 1, then this is specific to my communication and it's going to apply this policy, or actually this rule right here. If I'm anybody else, 10.10.10.5, then that's all other IP traffic and it's just going to block me regardless. Now let's go ahead and take a look at what actually happens when we use this require security action between DC Nugget 1 and DC Nugget 3. When we go into that, we look at this filter action for require security. If we double click on it or click on edit down here, then we see exactly what it's doing. It's got a custom security type, and we'll click on edit here to see exactly what it's trying to do, which takes us to this custom radio button where we have the settings. It's only using encapsulating security payload. I could use this as well as authentication header with MD5 or SHA-1 and hash if I want. But it's really kind of overkill because included in ESP is a certain level of authentication, so I don't necessarily need to have that. Now the other thing I could choose is to deselect this item and only select AH, or authentication header. What this would do then would to not encrypt the payload. Someone could still pick it off the wire using a packet sniffer and analyze the contents. However, what this would do with the SHA-1 integrity algorithm is use a hashing method to make sure that both parties are indeed who they say they are, so I can at least be sure that nobody's spoofing an IP address or faking that they have an IP address when they really don't. Now my integrity algorithms here are the weaker MD5, which is 128-bit encryption, or SHA-1, I say 128-bit algorithm, I should say, or SHA-1 integrity algorithm, and that's 160-bit. Well, the difference between 128 and 160 is 32. And with bits, every time you add an additional bit, you double the number. So when you take 32, remember from your IP addressing schemes and all that, how many numbers in binary is 32? Well, that's a possibility of 4 billion numbers. So that means that anybody that wants to crack a SHA-1 hash will have to work through 4 billion more numbers than they would have had to work through to get an MD5 hash. So try to go with SHA-1, of course. The only drawback to any of this is your network traffic and your burden on the processor, because SHA-1, of course, is going to require a higher level of math and a higher level of processor utilization. In any case, then we can also go to this encapsulating security payload, where we have the same integrity algorithms to choose from, or for our encryption algorithm, which does encrypt the payload of the packet, we could choose DES, Digital Encryption Standard, which is a 56-bit key that it encrypts with, or we could use Triple DES, which does this. It's a 56-bit key to encrypt, then it's a different 56-bit key to decrypt, and then it's a third 56-bit unique key to re-encrypt the data, and that is pretty doggone tough encryption. It's kind of an encryption blender that it goes through here. So that's really the best level of encryption. If you can use it, go ahead and do so. But remember, Windows 2000 needs to have at least Service Pack 2 or the high encryption pack. And if you can't use that with Windows 2000, you'll have to drop back to DES only. So most of your Windows 2000 machines, if you still have them, should have at least Service Pack 2 on them anyway. Now, your session key settings relate to this. There's a security association that's established between both endpoints here. And there's a key that's used to do that. It's a session key that's generated there. Now, what you can do is to regenerate that every 100 megabytes or 900 seconds, whichever comes first. That way, even if a hacker is able to pick packets off the wire and somehow reverse engineer the packets and somehow come up with the session key, by the time they figure it out, because that's very time intensive to figure that kind of thing out, by the time they figure that out, it's already an expired key and you've already got another key, so it doesn't really matter to them anymore. Alright, so that's what we've got going on for this. Now let's go back to where we originally were here. The security method preference order. What's supposed to happen here is you can arrange these by moving up or down, as you see the various buttons over here on the right-hand side. You can move these up and down in order of preference. And what will happen is, if the remote host that's trying to communicate with me does not support triple DES, for example, then it'll go through this, won't be able to communicate with it. Maybe it's an older Windows 2000 machine that's not service packed. Then it won't be able to support this one either, because that's also triple DES. Finally, when we get to DES, well, it can support DES and SHA-1, so then we'll be able to start communication. However, you got to be really careful about this kind of thing, because a lot of network applications, by the time they get down to this, the network application may stop responding or time out, because it takes time to realize it won't be able to negotiate here, won't be able to negotiate here. Finally, it realizes it can negotiate here. So just be careful about the order of this, especially if you've got backwards compatibility to keep in mind. And then notice that we can always accept unsecured communication. However, we will always respond using ipsec. And if the destination doesn't understand ipsec, it's a Windows 95 or 98 machine or something, or it's a Windows XP or 2003 machine that doesn't have ipsec enabled, then communication simply stops. And then alternatively, there's also another option down here, allow unsecured communication with non-IPsec aware computers. What will happen there is, it'll first try to communicate using these methods, and then when it gets to the weakest bottom one here, it finally realizes there's no way for us to talk together. Then we'll just go ahead and allow communication unsecured. Now that sounds pretty insecure, and in a way it really is, but you have to use that in some situations where you have a mix of computers on the network where some, like NT4, Windows 95, will not be able to communicate using IPsec. So this is just the lesser of two evils. And if you click on that, then you get a big warning here saying you're not going to get any authentication or encryption and so forth. Are you sure you want to do this? Yes. And then that's what you have. And then we have use session key perfect forward secrecy. Now, what this has to do with is that the fact that there is a master key that's generated when security negotiations first take place, and it's generated off of a Diffie-Hellman algorithm, which is a very complex algorithm. The beauty of Diffie-Hellman is that both ends of the communique can come up with the same result without ever exchanging a common key across the network. Well, anytime you regenerate new session keys, which we talked about just a little while ago, if you also select this checkbox, then it'll also regenerate that master key as well, making anybody's attempt at cracking your keys even more difficult because they're based on different math now. All right, so we okay past all of this, and we just left all the settings the way they were there. And then we'll go ahead and close this up. And then when we come back into this, we again have our two security rules in play, but there's also a general tab that you should be aware of. And this is just general information up here at the top. It'll check for policy changes every 180 minutes between the hosts, just to make sure that the other host hasn't changed its negotiation method or something like that. And then it'll perform key exchange settings using additional settings. If we click on those, we see that what happens is, again, you can choose to master key perfect forward secrecy, which means, again, with your master key, you can cause it to regenerate every X number of minutes if you like. And then you can also specify how many sessions it's good for if you like. So I want to regenerate a new master key every, 40 sessions or something like that. Again, it just helps to mix up the math and make it more difficult to interpret or to break any keys. Now, you can protect the identities with the various Internet key exchange security methods. And what we have for this is, again, triple DES with SHA-1. And then if we click on Edit for this, we can see a little better picture here. The final part of the key there is the Diffie-Hellman group, which I mentioned a little while ago. This is actually a predecessor to the RSA version of algorithms, but what we have with this is a pretty easy-to-use algorithm. It starts off with a low algorithm of 768 bits. You can go to medium, which is supported at 1024 bits, and which Windows 2000 will also support. Or you can choose high of 2048 bits, which only Windows Server 2003 will support, regardless of service packs or any other upgrades to previous operating systems. Now, I also mentioned that Diffie-Hellman was a predecessor to RSA. Well, that makes RSA sound newer and shinier, so why don't we just use that? Well, Diffie-Hellman is lighter on performance, and you're still pretty darn tough at medium or high level of algorithm here. And then what happens with Diffie-Hellman here is that both sides of the communique are going to share publicly certain information about the key, or keying material, if you will. In addition to that, Windows XP and Windows Server 2003 systems will further protect it with a hash function signature. So you kind of got hashing on top of hashing. And then neither side of this communique will ever exchange the actual keys involved in the Diffie-Hellman group algorithm. However, once they receive the keying material on both ends, they can each still generate the same identical key locally. So that Diffie-Hellman group stuff there is pretty ingenious stuff. All right, so let's go ahead and cancel out all of this, and that's pretty much it for this policy. We now have a policy that will block all traffic except for ESP between DC Nugget 1 and DC Nugget 3. Now, the next thing I would need to do then is to go to DC Nugget 3 and either create a new policy from scratch identical to this one, with the exception of my IP address and the source IP address, flipping those around because it's on the opposite end of the connection. Or what I could do is to make this easier on myself and right-click in an empty space here, choose all tasks, and then I could just export the policies, and then I'll just name it ipsec.ipsec. Save it. I'll just go ahead and replace it. And then I could transport this saved file over to DC Nugget 3, import it on that end, and make whatever minor modifications I need to for that end of the communication. Note, by the way, that when you export that, like I just did, it doesn't export just this one policy. It exports all of the policies that I might have listed here. You can't pick and choose on a onesie-twosie basis there. So now what I'm going to do off screen here is I'm going to go ahead and export it like I just did. Then I'll import it on the other end of the communique at DC Nugget 3, and then we'll go ahead and test out a connection. Now in the next nugget, we're going to go ahead and discuss how to actually implement the policy that we just created. We'll actually see it in action. For the time being, however, let's just review what we've already discussed with IPsec. In this part 1, we discussed the various IPsec policy components. which consists of filter lists, which consists of filter actions, varying levels of integrity checking, things like this, as well as encryption for ESP. So we look at all the various parts of a policy, and then we briefly created an IPsec console so we could create our own policy. Then we also created that policy, which was a little different than what we might have done if you looked at other series that I've taught, because in this one, we also taught it how to do two different things at once, if you will, and that is to block all traffic while making an exception for a specific IP address. And we also took a look at a network diagram so that we could see how this might have practical use in a real-world environment. I hope this has been informative for you, and I'd like to thank you for viewing.